linear equations by elimination method, right? Let's answer number. Doesn't really matter which number we want to answer in here. It's up to you guys. 11 or 14. Cecilia, just choose 11. Let's try number 11. Let's read the equations in there. Go ahead, Cecilia.
4x squared minus 9y equals 36. 4x squared plus 9y equals 36.
First, 4x squared minus 9 squared equals 36. And the other one, 4x squared plus 9 squared is again another 36, right? Oh, 4x squared minus 9 squared equals 36. And the other one is 4x squared plus 9 squared equals another 36. Are we correct?
The 4x has to be squared.
Oh, yeah. In here. Thank you. Thank you. Yeah. Let's call them equations 1 and 2 for now. Okay. Okay. Let's read our step 0 first for elimination method. Thomas, go ahead.
Make sure that the given equations intersect.
All right. Very good. Right. Because honestly, let's do this by graphing, because if they don't intersect, then no need to do the entire elimination method, right? So let's see first if they actually intersect. Let's put the first one, 4x squared, here we go, minus 9 squared, y squared is equal to 36. Yeah. Conic sections, if you are familiar with conic sections, this is called a hyperbola. Okay, hyperbola. Okay. The other one, we have the following, 4x squared, there we go, plus 9y squared, there we go, is another 36. As you may notice, that's a what? An ellipse, right? There we go. Almost a circle, right? But more oblate, right? Do you know that the Earth is not a sphere, but a what? Anyone who knows what shape our Earth is? Oblate spheroid, right? When you say oblate spheroid, then that means what? It's flat on the poles, right? Bulging on the equator, right? Simply because obviously in physics, if you are rotating for millions, billions of years, it's gonna flatten the poles and it's gonna bulge the equators as well. Are we good? Right? Good? Right. I mean, imagine spinning for like billions of years. Definitely, it's gonna bulge the sides and flatten the poles. Are we good? So we're not basically we're not sphere, we're oblate sphere. Similar to this, right? But not that flat. Are we good? Right? So going back, let's see where they intersect, right? So as you may notice, at least it's manageable, right? We know that they do intersect, right? Once again, if you see that they're whole numbers already, you're done, right? But just for the sake of elimination method, let's do the process itself. Again, you don't have to do this if you have the answer in integer or simplified fraction form already. But if you need to do such, then let's do it in here. Ready, guys? Okay. Step number 1. Let's go, Victor. Choose one variable to eliminate. All right.
Usually the one is
Simple ratio, right? So again in here, they're both basically just the same ratio, right? I would say choose the one that has what? Inverses already, or negatives of each other, right? Let's read step number 2. Logan.
Multiply both or one of the equations such that the numerical coefficient of chosen variable are negative.
Negative. So which among those, x's or y's, has negatives? The y's, right? So in short, remove the y, right? So as simple as that one, guys. Just add these two together. The y's will cancel out, right? Negative 9 plus 9. What about the 4x squareds? Kylene, what's that? 4x squared plus another 4x squared. 8x squared, very good. And then in here, 36 plus another 36. Very good. Adam. You add these two together. 72. Very good, right? Now what do we do in here? So that's what we did. align the similar terms and add them together, right? And then, step number 4, Lexani.
Solve for the remaining variable.
Alright, solve for the remaining variable, right? So what's the remaining variable? X, right? So how do you solve for that X? Bryce, what do you do first? Very good. Alright, and so such x squared is equal to, so you just make your calculator useful, you're gonna get the answer. Question, 72/8. Calculator. Very good, right? We just want x. How do you move that square? Okay, Anna?
Oh, you square root again.
Square root both sides. There we go, right? So x is equal to, what's square root of 3? Square root of 9? I'm getting ahead of myself, right? Do not forget plus or minus if you're squaring, getting the square root of both sides, right? So basically in here, it just tells us that one is 3 and the other is negative 3, right? Let's call it one. x1 and x2, 2x values. Are we good? Right? Step number 5, all right? McKinsey.
Substitute this obtained value to any given equation to solve for the other variable.
So it doesn't matter if you use equation 1 or equation 2. I would say just use equation 2, right? Because at least it's plus. Get it? Okay, so substitute it back in here on equation 2. Call it back substitute. Okay, let's do it. Let's do it again. 4, what's your x again? 3 first, right? 3 squared plus 9y squared equals 36. Alright, so what's this gonna be on your calculator? 4 times 3 squared. Thomas? 36, right? Right, so this is 36 plus 9y squared is equal to 36, right? What do we do next? Kylene?
Minus 36.
Minus 36 both sides. So you're gonna get what? 9y squared is equal to what? 0. We good? Get it? Okay. Hence, if you square root both sides, divide both sides by 9 as well, your y basically is what? 0. And again, since 0 is not neither positive nor negative, just leave it as it is. Are we good? Right. Now do the same in here for negative 3. So this is your y1, right? Good. For x2, you're going to do the same, right? 4 times negative 3 squared plus 9y squared equals 36, right? You're going to do the same whole thing anyways as well. Again, negative 3 squared is just the same positive. It's going to be the same 36 plus 9y squared is equal to 36. And with that being said, what y2 will you get from here?
0.
Eva? In here.
0.
0, right? And yes, very good. 0. Get it? Okay. Step number 6, the last. Answer. How do we get the answer in here? McKinsey, express answers or answer in
an ordered pair and verify by graph.
Thank you, right? And again, what our answer are as follows, right? That would be 3, 0, and the other one at negative 3, 0. Good. Always have your answer in ordered pair notation, and you can verify it by graphing, right? You see on your graph, x1, y1, 3, 0, x2, y2, negative 3, 0. Again, you don't have to do this if by graphing you got an integer or whole number or at least a simplified fraction answer, right? Only do it if it is necessary. How we get that? Any questions? Thank you all so much, and we're gonna continue with linear inequalities next time, all right?